What if everything you thought you knew about the universe was just the tip of the cosmic iceberg? Picture this: somewhere out there, a star is belching alcohol into space. A black hole is spinning so fast it could warp time itself, and entire planets might be made of diamond. The cosmos is far stranger than our wildest sci-fi fantasies, and today we're diving into 30 galactic facts so bizarre they'll make you question reality. This isn't just a list, it's a journey through the weirdest corners of space, where the laws of physics seem to take a coffee break and the universe shows off its most outrageous secrets. Think space is just a silent, empty void. Think again. Out there, hidden in the darkness, are screams from dying stars, planets where it rains molten glass sideways, and neutron stars so dense a single teaspoon would weigh as much as a mountain. And that's just the warm-up. We're talking about a universe where entire galaxies are cannibalizing each other, where time slows down near massive objects, and where some stars are older than the universe itself, at least according to our current math. How is any of this possible? Buckle up, because we're about to peel back the curtain on the cosmos's most mind-bending tricks. But here's the real kicker: we've barely scratched the surface of what's out there. Every discovery we make just leads to more questions, more head-scratching anomalies that remind us how little we truly understand. That's the magic of space. It doesn't care about our expectations. It's a place where logic takes a backseat and wonder takes the wheel. So if you're ready to have your brain twisted by the universe's most outrageous secrets, stick around. By the end of this, you'll never look at the night sky the same way again. Imagine a world where the ground beneath your feet isn't rock or sand, it's solid diamond. Meet 55 Cancri E, a planet so extravagant it makes Earth's most precious gems look like pebbles. Located just 40 light-years away, this insane world is literally made of crystallized carbon, forged under crushing pressures and searing temperatures. Scientists estimate its diamond core could be worth $26 nonillion. That's a 26 followed by 30 zeros, enough to bankrupt every economy on Earth a trillion times over. But here's the wild part: this planet shouldn't exist. Normally, planets form from the same swirling gas and dust as their parent stars, rich in lightweight elements like oxygen and silicon. But 55 Cancri E defies the rules. It's a carbon-heavy freak of nature, likely birthed from a protoplanetary disk packed with soot-like particles. Picture a cosmic pressure cooker where carbon atoms get squeezed so tightly they snap into diamond lattices, creating a surface that might glitter like a cosmic disco ball. And the conditions brutal. This planet orbits so close to its star that a single year lasts just 18 hours, with surface temperatures hot enough to vaporize steel. Some theories suggest it might even rain molten diamonds in its scorching atmosphere. What's truly mind-blowing isn't just the planet's opulence, it's what it reveals about the universe's creativity. If diamonds can form entire worlds, what other impossible treasures are lurking out there? 55 Cancri E forces us to rethink everything we know about planet formation, proving the cosmos has a flair for drama even Hollywood couldn't script. And remember, this glittering monster is practically in our backyard. So the next time you gaze at the stars, know this: somewhere in that darkness, there's a planet where mountains are made of gemstones, and the very ground is a fortune waiting to be claimed. Now picture a planet cut loose from its star, tumbling through the endless dark like a cosmic orphan. These aren't sci-fi fantasies, they're rogue planets, and billions of them are wandering our galaxy alone. Unlike Earth, which basks in the sun's warmth, these nomads wander in perpetual night, untethered from any solar system. Some were violently ejected from their birthplaces by gravitational chaos, while others may have formed in the freezing depths of space from collapsing gas clouds. Imagine a world where the sky has no sunrises, no constellations, just an eternal black canvas dotted with distant stars. But here's where it gets fascinating: these drifting worlds might not be barren wastelands. Deep beneath their icy surfaces, tidal forces or radioactive decay could maintain vast liquid oceans, shielded from the cold vacuum of space. On Earth, we've found life thriving in the most extreme conditions near boiling hydrothermal vents in acidic lakes, even inside solid rock. If life can cling on here, why not in the hidden seas of a rogue planet? Some scientists speculate these dark wanderers could be the most common habitable real estate in the galaxy, far outnumbering Earth-like planets. The catch, spotting them is like finding a single unlit match in a football stadium. Without a star's glow to illuminate them, rogue planets are nearly invisible. We've only confirmed a handful, usually when their gravity briefly bends the light of a background star, a cosmic microlensing event lasting mere hours. Future telescopes might scan for the faint heat signatures of young rogue planets, still warm from their formation. Until then, these drifting worlds remain one of space's most haunting mysteries, dark, untethered, and possibly harboring secrets we've yet to imagine. Think about that the next time you feel adrift somewhere out there. Entire planets are navigating the cosmos solo, proving the universe has a way of thriving even in the loneliest places. Deep in the cosmic void, something massive is tugging at our galaxy with irresistible force, and we can't even see it. Meet the Great Attractor, a gravitational mystery so powerful it's dragging entire galaxies, including our Milky Way, toward it at over 14 million miles per hour. But here's the cosmic irony. This invisible heavyweight lurks directly behind the Milky Way's zone of avoidance, a region so packed with stars, gas, and dust that telescopes practically go blind trying to peer through it. It's like having a neighbor blasting music next door, but your walls are soundproof. You feel the vibrations, but the source stays hidden. What could possibly wield such gravitational muscle? One leading theory points to the Norma cluster, a dense gathering of galaxies about 250 million light-years away, combined with the surrounding Laniakea supercluster, a cosmic web where galaxies flow like rivers toward this gravitational sinkhole. But some calculations suggest even that might not fully explain the pull. Could there be something even more exotic at play? Dark energy, a concentration of dark matter so dense it warps spacetime itself. Or perhaps a flaw in our understanding of gravity on intergalactic scales. The strangest part, this isn't just some distant anomaly. The Great Attractor is pulling us along with every galaxy in our local group on a one-way trip toward an unseen fate. By the time we get there in tens of billions of years, the universe's expansion might have stretched space so much that the attractor's grip loosens, leaving us forever chasing a receding horizon. For now, it remains one of astronomy's most tantalizing puzzles. A reminder that even as we map the cosmos, the universe keeps its greatest secrets just out of sight, lurking in the shadows behind our own celestial backyard. So the next time you look up, know this: somewhere beyond the Milky Way's glittering veil, an invisible titan is calling the shots, bending the paths of galaxies like a puppeteer pulling strings. And we're all along for the ride. Most places in space are unimaginably cold, but the Boomerang Nebula takes cosmic chill to another level. It's literally colder than the void around it. At a bone-shattering negative 272 degrees Celsius, this eerie cloud of gas is just 1 degree above absolute zero, the theoretical temperature where all motion stops. To put that in perspective, even the cosmic microwave background, the faint afterglow of the Big Bang, is warmer at negative 270 degrees. This nebula doesn't just flirt with the coldest possible temperature in the universe, it holds the record. So how does a cosmic structure become colder than space itself? The answer lies in its dramatic death throes. At the nebula's heart, a dying star, once similar to our Sun, is shedding its outer layers at breakneck speeds. As the star's expelled gas races outward at nearly 164 kilometers per second, it expands so rapidly that it chills itself, much like how a can of spray paint feels icy as the gas inside escapes. The result, a sprawling, bow-tie-shaped cloud of hypercooled material that glows faintly in the darkness. That bizarre shape, resembling a cosmic boomerang, is actually an illusion. We're seeing the dense waste of a far larger hourglass structure, with twin lobes of gas stretching over 3 trillion kilometers in opposite directions. But here's the twist. The Boomerang Nebula isn't just a cosmic freezer, it's a time capsule. The star's violent gas loss is a preview of what our own sun might do in about 5 billion years. Unlike a supernova, which goes out with a bang, this star is fading with a cold, slow whisper, transforming into a ghostly planetary nebula. And because the gas is so cold, molecules that would normally be destroyed by radiation elsewhere in space can survive here, giving scientists a rare laboratory to study chemistry in deep freeze. What's truly humbling is the scale of this cosmic chill. The nebula's expansion has created a refrigerator larger than our entire solar system, a place so frigid that even the laws of thermodynamics seem to pause. It's a reminder that the universe doesn't just deal in fire and fury. Sometimes, the most extreme places are the quietest, coldest, and most hauntingly beautiful. So the next time you shiver on a winter night, remember, somewhere out there, an entire nebula has turned cold into an art form. Some stars don't just drift peacefully through the galaxy, they are hurled into the void like cosmic bullets. These are hypervelocity stars, and they're racing away from the Milky Way at over 1 million miles per hour, fast enough to cross the entire United States in less than 10 seconds. What kind of force could launch a star with such violence? The answer lies in the heart of our galaxy, where a supermassive black hole named Sagittarius A star reigns supreme. When a binary star system, a pair of stars locked in orbit, wanders too close to this gravitational monster, things get messy. The black hole's immense gravity can tear the stars apart, capturing one while violently flinging the other into the abyss like a slingshot. The ejected star rockets away at speeds so extreme, it could one day break free from the Milky Way entirely, becoming a lone traveler in the darkness between galaxies. But here's the twist. These runaway stars aren't just celestial speedsters, they're time capsules. By tracing their paths backward, astronomers can map the Milky Way's gravitational history, uncovering clues about how our galaxy evolved. Some hypervelocity stars might even be invaders from other galaxies, hurled our way during ancient cosmic collisions, and their journeys aren't just relics of the past. Right now, dozens of these stars are screaming through the galaxy's outskirts, their light stretched into reddish hues by the Doppler effect, a telltale sign of their unbelievable speed. What's truly staggering is the fate awaiting these stellar fugitives. If they escape the Milky Way's grip, they'll drift forever in the freezing void, their light fading into oblivion. But until then, they're a reminder of the chaos lurking in our seemingly orderly galaxy, proof that even stars aren't safe from the universe's reckless side. So the next time you gaze at the night sky, know this: somewhere up there, a star is fleeing home at unimaginable speeds, and it's never looking back. Our cosmic neighborhood isn't just peaceful starlight, it's a battlefield littered with galactic cannibals, and Andromeda wears the crown. Just 2.5 million light-years away, our nearest spiral neighbor has spent billions of years feasting on smaller galaxies, leaving behind trails of devoured stars like cosmic breadcrumbs. These ghostly stellar streams, stretched across space by Andromeda's relentless gravity, tell a violent story, one where entire galaxies get torn apart and absorbed. One victim, a dwarf galaxy called M32, was stripped so thoroughly that only its dense core remains, orbiting Andromeda like a prisoner on a leash. But how do we know this cosmic carnage happened? The evidence is written in starlight. Telescopes have spotted vast, looping ribbons of stars, remnants of galaxies ripped to shreds, wrapped around Andromeda's disk. Some streams are so faint they're barely visible, requiring hours of exposure to detect. Others, like the giant southern stream, stretch hundreds of thousands of light-years, a graveyard of stars orbiting in eerie silence. Even more chilling, Andromeda's appetite isn't sated. Right now, it's digesting another dwarf galaxy, its stars slowly being pulled into the spiral's glowing core. And here's the kicker, we're next. In about 4 billion years, the Milky Way and Andromeda will collide in a gravitational dance so slow it'll feel like watching continents drift. Stars won't crash, they're too far apart, but the galaxies will warp and merge, their spiral arms unraveling into a chaotic swirl. The result, a colossal elliptical galaxy astronomers nicknamed Milkomda, where the night skies of future civilizations, if any still exist, will glow with blended starlight. But don't panic, this cosmic car crash is more of a slow-motion tango, a reminder that even galaxies aren't immortal. What's truly humbling is the scale of destruction. Andromeda didn't just swallow a few galaxies, it built its empire on their remains. And one day, the Milky Way stars will join that legacy, scattered across a new galactic kingdom. So the next time you spot Andromeda with the naked eye, a faint smudge in the night sky, remember, you're looking at a predator, patient and relentless, and we're already in its sights. Black holes aren't just cosmic vacuum cleaners, they're messy eaters, and their table manners leave behind interstellar breadcrumbs. When a black hole tears apart a star or sucks in a cloud of gas, it doesn't vanish silently. Instead, it belches out bursts of X-rays so powerful they can outshine entire galaxies. But here's the twist, some of those X-rays don't arrive all at once. They bounce off the swirling maelstrom of debris orbiting the black hole, creating eerie, delayed echoes that scientists can detect like cosmic sonar. These echoes aren't just haunting, they're the key to mapping the most chaotic environments in the universe. Picture this, a star drifts too close to a black hole's gravitational grip, and tidal forces stretch it into a noodle of superheated plasma. As this stellar spaghetti spirals inward, it forms a seething disk of material called an accretion disk, where friction heats it to millions of degrees. The inner edge of this disk is where physics gets weird. X-rays blast outward, but instead of racing straight to us, some ricochet off the disk's far side, taking a detour through warped spacetime. By measuring the time delay between the initial burst and its echo, astronomers can calculate the black hole's size, spin, and even the shape of its gravitational whirlpool. It's like listening to a cave's echoes to guess its depth, except the cave is a monster bending the fabric of reality. The real magic lies in what these echoes reveal about the unseen. Black holes themselves are invisible, but their messy eating habits cast shadows we can study. In 2022, researchers used echoes from a black hole called Izwiki-1 to map its accretion disk with precision, uncovering regions where material swirls at half the speed of light. Some echoes even hint at structures within the disk, clumps of matter or magnetic tornadoes twisting space itself. And because every black hole's echoes are unique, they act like fingerprints, helping scientists categorize these cosmic beasts based on how they dine. But here's the kicker, these echoes might solve one of astrophysics' biggest mysteries: what happens to information swallowed by a black hole. Quantum physics says information can't vanish, yet black holes seemingly erase it. If echoes carry scrambled data about the material they devoured, they could be the universe's way of keeping receipts. That's the beauty of these cosmic lighthouses. They don't just illuminate black holes. They flicker with secrets about the laws of physics at their most extreme, proving even the darkest corners of space can't hide their truths forever. So the next time you hear about a black hole's echo, remember, it's not just noise, it's a message from the edge of oblivion, written in X-rays and space-time itself. We've found moons before, but nothing like Kepler 1625 b, a staggering Neptune-sized behemoth orbiting a planet 10 times heavier than Jupiter. This isn't just a moon, it's a cosmic rule breaker, challenging everything we thought we knew about how satellites form. For context, our solar system's largest moon, Ganymede, is only about 4% Earth size. Kepler 1625b. It dwarfs entire planets, stretching the definition of moon to its absolute limit. So how does something this massive end up as a moon rather than a planet? The leading theory suggests chaos. Billions of years ago, this oversized moon might have been an independent planet, wandering too close to its current host and getting captured in a gravitational tug-of-war. Alternatively, it could be the surviving half of a failed binary planet system, two worlds born together, where one starved the other of growth material before locking it into eternal orbit. Either scenario would rewrite the textbooks, proving moons can form through violent, unpredictable processes. The evidence comes from subtle dips in starlight. When astronomers studied the planet Kepler 1625b transiting its star, they noticed extra dimming before and after the main event, the telltale signature of a gigantic moon trailing its host. But skepticism lingers. Some researchers argue the data could show atmospheric fluctuations or instrument glitches rather than a moon. Others point out that a capture scenario would require precise conditions to prevent the moon from either escaping or crashing into its planet. What's undeniable is the thrill of the hunt. If confirmed, Kepler 1625b would be the first exomoon ever discovered, opening a new frontier in planetary science. Imagine oceans deeper than Earth's, swirling under the gravitational pull of its colossal planet, or skies stretched by tidal forces into permanent auroras. This isn't just about finding a moon, it's about discovering a whole new class of worlds that shouldn't exist, yet defiantly do. The universe, it seems, has a flair for the impossible, and we're just beginning to scratch the surface of its secrets. At the heart of our galaxy, a silent predator feasts in the dark Sagittarius, a star, the supermassive black hole anchoring the Milky Way. While most black holes lurk unseen, this one puts on a show, tearing apart gas clouds with such violence that the resulting flares outshine our sun by 100 times. But these aren't random bursts of energy. They're the aftermath of a cosmic slaughter, where gravity shreds matter into spaghetti like strands before swallowing it whole. Recent observations reveal just how messy these meals can be. In 2019, astronomers witnessed a mysterious object called G2, likely a doomed gas cloud drifting too close to Sagittarius, a star. Instead of vanishing quietly, it stretched into a chaotic stream, triggering flares that flickered like a dying candle for years. The black hole didn't just gulp it down, it played with its food, creating shockwaves that lit up surrounding gas like neon signs in a fog. Even stranger, some material escaped, ejected at near light speed in twisted jets, a cosmic version of a toddler flinging spaghetti across the room. But the real spectacle might still be coming. Later this decade, another gas cloud, X7, is on a collision course with the black hole's gravitational jaws. Its fate could rewrite what we know about these cosmic beasts. Will it fragment quietly or erupt into a light show visible across the galaxy? Either way, it's a front-row seat to destruction on an unimaginable scale. What makes Sagittarius, a star's feeding habit, so fascinating isn't just the violence, it's the aftermath. As material spirals inward, friction heats it to billions of degrees, creating a swirling, accretion disk that glows with X-rays. Sometimes the disk hiccups, belching flares that ripple across space-time. Other times it chokes on oversized bites, like in 2021 when a record-breaking flare suggested the black hole had gulped something unexpectedly hefty, perhaps a wandering asteroid or a failed star. Here's the kicker: Sagittarius, a star, is actually a picky eater. Despite its 4 million solar mass heft, it's relatively quiet compared to other supermassive black holes. Most of its meals slip past unnoticed, vanishing without a trace, but when it does dine, the universe bears witness. These flares aren't just cosmic fireworks, they're laboratories for testing Einstein's theories, proving space-time can warp like taffy under extreme gravity. So the next time you glance toward the constellation Sagittarius, know this: Hidden in that direction, a monster is playing with its food, and every flicker of light is a clue to the most extreme physics in the galaxy. And one day, long after our sun burns out, even the Milky Way itself will be on the menu, a final feast before the darkness wins. Some stars don't just defy expectations, they laugh in the face of cosmic logic. Take HD 140283, nicknamed the Methuselah star, a flickering relic so ancient it appears to be older than the universe itself. Clocking in at 14.5 billion years, this celestial senior citizen predates the Big Bang's estimated 13.8 billion year timeline by a staggering 700 million years. At first glance, that's like finding a birth certificate claiming someone is older than their own country. So how does this cosmic paradox exist without unraveling everything we know? The answer lies in the delicate art of stellar archaeology. Unlike dating fossils on Earth, pinpointing a star's age involves measuring its composition, brightness, and motion with painstaking precision. Methuselah is a metal-poor subgiant, meaning it formed from nearly pristine gas left over from the universe's infancy before supernova seeded space with heavier elements. Its lack of metallic content suggests extreme age, but here's where uncertainty creeps in. Initial estimates relied on assumptions about its distance and brightness that, if slightly off, could skew the age calculation. Newer data from the Hubble Space Telescope adjusted the star's distance by just a few light years, trimming its estimated age to around 14 billion years, still eyebrow-raising, but now within the margin of error for the universe's birth. But the plot thickens. The Methuselah star isn't just old, it's fast. Hurtling through space at 800,000 miles per hour, its elongated orbit suggests it was flung here from an ancient dwarf galaxy devoured by the Milky Way long ago. That violent past might have stripped away some of its outer layers, altering the very properties astronomers used to date it. Combine that with potential quirks in nuclear fusion, rates, or undetected stellar companions, and suddenly the age paradox starts to look more like a cosmic rounding error. What's truly fascinating isn't the discrepancy itself, it's what it reveals about the limits of our knowledge. The universe's age comes from measuring the cosmic microwave background radiation, while stellar ages rely on entirely different methods. When two pillars of science clash, it's not always a sign that one is wrong. Sometimes it means we're missing a piece of the puzzle, like the role of dark energy in the early universe's expansion or undiscovered stellar physics. Methuselah isn't breaking the laws of cosmology, it's challenging us to refine them. So the next time you hear about a star older than time, remember, the universe keeps its deepest secrets closely guarded, and even the most precise calculations come with asterisks. The Methuselah star isn't a mistake, it's a reminder that the cosmos still has stories left to tell, and some of them might rewrite the chapters we thought we knew by heart. Galaxies aren't just drifting, they're racing towards something we can't see, pulled by a force beyond the edge of the known universe. Astronomers call it the dark flow, and it's one of cosmology's most unsettling mysteries. Imagine throwing a handful of paper airplanes into the wind, only to watch them all veer sharply in the same direction, defying every law of physics you understand. That's what's happening to entire galaxy clusters, hurtling toward a distant void at speeds exceeding 2 million miles per hour, as if the universe itself is tilted. The culprit, something colossal lurking in the unreachable darkness past the cosmic horizon. This isn't just gravity as we know it. The dark flow's pull extends over billions of light years, far beyond where the Big Bang's afterglow fades into blackness. Normally, galaxies move apart due to the universe's expansion, with occasional local nudges from neighboring clusters. But in the 2000s, researchers analyzing X-ray galaxy data noticed hundreds of clusters streaming toward the same patch of space near the constellations Centaurus and Vela. The kicker, there's nothing visibly massive enough there to explain it. no supercluster, no great attractor level anomaly, just emptiness. Theories range from the mind bending to the existential. One possibility: our universe is caught in the gravitational wake of another universe, a neighboring bubble in the multiverse brushing against ours like ships passing in an infinite sea. Alternatively, the flow could trace back to a primordial flaw in spacetime itself, a kink left over from the Big Bang's first fractions of a second when the cosmos was a seething quantum foam. Some even speculate it's evidence of a higher dimensional structure warping our reality from outside our perceptual reach. What makes the dark flow so unnerving is its defiance of cosmological orthodoxy. The observable universe is supposed to be roughly uniform, with matter evenly distributed at large scales. Yet here we are, watching galaxies march in lockstep toward a cosmic siren call we can't hear. Future telescopes might peer deeper into this enigma, hunting for distortions in the cosmic microwave background or searching for hidden mass beyond our sight. Until then, the dark flow stands as a stark reminder. The universe we see might just be the lobby of an infinitely stranger hotel, and check-in time is forever. Most stars go out with a bang, but some refuse to die. Meet the cosmic zombies, stellar survivors that cheat death in the most violent way possible. When a white dwarf star siphons too much fuel from a neighboring star, it typically detonates as a Type Ia supernova, obliterating itself completely. But Type IX supernova are different. These rare explosions aren't quite strong enough to finish the job, leaving behind a charred, mangled remnant that keeps limping through the cosmos. Picture a firework that fizzles instead of flashing, only in this case the firework is a star, and the fizzle still unleashes the energy of 100 million suns. What makes these zombie stars so fascinating isn't just their refusal to die, it's what they leave behind. While classic supernovas scatter their ashes across light years, Type IX blasts are messy and incomplete, often leaving a surviving core known as a zombie white dwarf. This remnant, battered but intact, gets kicked away at incredible speeds, sometimes fleeing its own explosion at over 3 million miles per hour. Imagine a ship weathering its own torpedo blast, then sailing away with gaping holes but still afloat. That's the defiance of these stellar undead, yet their greatest legacy might be what they contribute to the universe. Even failed supernova cook up heavy elements in their fury, forging carbon, oxygen, and iron in the crucible of partial destruction. Over billions of years, these elements get recycled into new stars, planets, and even life itself. In a way, zombie stars are cosmic alchemists turning destruction into creation. They're also living, or rather, undead laboratories. By studying their light curves and remnants, astronomers can decode the delicate balance between stellar explosions that annihilate and those that leave survivors. The irony: these stars might hold clues to one of astronomy's biggest puzzles. What triggers supernova in the first place? Most models assume total destruction, but zombie stars prove reality is messier. Maybe some white dwarfs ignite unevenly, or perhaps companion stars play unexpected roles in the explosion's intensity. Every new Type IX discovery chips away at our assumptions, revealing a universe where even death isn't always final. So the next time you hear about a supernova, remember, some stars don't just die. They rise from their own ashes, forever changed but stubbornly alive, whispering secrets about how the universe builds itself from chaos. And somewhere out there, a zombie star is drifting through the dark, carrying the scars of a battle it somehow survived. We know where most of the universe's matter should be, but for decades, half of it simply vanished without a trace. This isn't dark matter we're talking about, but ordinary atoms. The protons, neutrons, and electrons that make up stars, planets, and even us. Theoretical models predicted these baryonic particles should account for about 5% of the cosmos. Yet when astronomers tallied up all visible galaxies, stars, and gas clouds, nearly half was missing. The answer: a ghostly highway of superheated gas threads, weaving between galaxies in a structure so vast and faint we only just learn to see it. These aren't just wispy tendrils, they're the backbone of the cosmic web, a network of plasma filaments stretching billions of light years. Imagine the universe as a sponge where galaxies cluster like droplets on its surface, while hidden channels of gas form the porous structure beneath. This intergalactic medium is scorching, reaching temperatures of millions of degrees, which ironically made it nearly invisible. Hot gas doesn't emit visible light. Instead, it glows in X-rays so faint they drown in the background noise of space. For years, telescopes lacked the sensitivity to detect them, but then came a breakthrough. Astronomers realized these filaments imprint shadows on the cosmic microwave background, the afterglow of the Big Bang. When high-energy photons from the early universe hit the hot gas, they scatter, leaving cold spots in the microwave sky like cosmic fingerprints. In 2017, the Planck satellite and ground-based telescopes finally pinned down the proof. By cross-referencing thousands of galaxy pairs, they spotted the predicted gas bridges, each containing more mass than all stars in the galaxies they connected. Some filaments stretch over 500 million light-years, making them the largest structures in the known universe. But here's the twist: this gas isn't just hiding, it's moving. Simulations suggest galactic winds and black hole jets constantly pump matter back into these channels, creating a dynamic recycling system where gas flows in and out of galaxies like breath in lungs. What's humbling is how much we still don't know. The filament's extreme temperatures defy easy explanation. Some regions are hotter than stellar cores, possibly heated by shocks from colliding galaxy clusters or energy leaking from dark matter interactions. Future X-ray telescopes like Athena aim to map this web in 3D, revealing how it fuels galaxy growth and distributes the heavy elements forged in supernova. Every discovery peels back another layer of the cosmic onion, proving the universe doesn't lose matter. It just tucks it away in places we're only beginning to explore. So the next time you stare at the night sky's scattered stars, remember, they're not isolated islands. They're nodes in a hidden labyrinth connected by rivers of fire so vast they make galaxies look like specks of dust, and we're just starting to trace their currents. Supermassive black holes aren't supposed to dance this way. 3 of them, locked in a gravitational waltz so precise it defies every simulation we've ever run. Meet the impossible quasar trio SDSS-J0849 plus 1114, where 3 supermassive black holes orbit each other in a space smaller than our solar system, each weighing hundreds of millions of suns. Normally, when galaxies collide, their central black holes spiral inward over eons, eventually merging in a universe-shaking event. But this system, it's stuck in cosmic limbo, a gravitational paradox that shouldn't exist according to our current models. The discovery shattered expectations. Using data from NASA's Chandra X-ray Observatory and ground-based telescopes, astronomers spotted the trio just 1 billion light-years away, practically next door in cosmic terms. Each black hole blazes as a quasar, guzzling surrounding gas so ferociously that their accretion disks outshine entire galaxies. But here's the twist: their orbits are stable. Theory says 2 black holes should merge within a few million years once they're this close, yet these 3 have somehow avoided that fate for at least 100 times longer. It's like watching 3 bulls in a china shop somehow tiptoe around each other without breaking a single plate. What keeps them suspended in this cosmic stalemate? The answer might lie in the chaos of their birth. When 3 galaxies collide simultaneously, a rare event, their black holes get funneled into the center through a complex interplay of gravity and gas dynamics. Simulations suggest the 3rd black hole acts like a cosmic referee, stealing energy from the other 2 and preventing their final plunge. Alternatively, their orbits could be parked in a gravitational sweet spot where tidal forces balance perfectly against the pull toward collision. Either way, their existence forces us to rewrite the rules of black hole mergers. the implications ripple across astrophysics. If black holes can stall like this, it might explain why we've detected far fewer gravitational waves from mergers than predicted. Perhaps the universe is littered with similar trios hiding in plain sight. Future telescopes like LISA, designed to sense low-frequency gravitational waves, could hunt for their telltale hum, a three-part harmony of space-time ripples. Until then, this trio remains a tantalizing puzzle, proving that even the most voracious monsters in the cosmos sometimes prefer an uneasy truce to a fatal embrace. What's truly humbling is the scale of their defiance. These black holes aren't just breaking the rules, they're revealing gaps in our understanding of gravity itself. Every second they delay their merger whispers a challenge to Einstein's equations, hinting that in the most extreme environments, the universe might play by a different set of physics. So the next time you hear about colliding black holes, remember, some don't collide at all. They linger, locked in a standoff so delicate it makes the cosmos itself hold its breath. Imagine a world where the sky rains molten glass not gently, but in sideways hurricanes faster than a speeding bullet. Welcome to HD 189733b, a planet so bizarre it makes hell look like a spa retreat. This distant exoplanet, 63 light-years away in the constellation Vulpecula, gleams like a cobalt-blue marble from space, a striking hue created by silicate particles in its atmosphere scattering starlight into a deep azure glow. But don't let its beauty fool you. This isn't a tranquil ocean paradise, it's a furnace where temperatures soar to 900 degrees Celsius, hot enough to vaporize metal and hurl liquid glass across the sky like cosmic buckshot. How does glass even form in such extreme conditions? The answer lies in the planet's atmosphere, thick with silicon dioxide, the same stuff that makes up sand on Earth. Under normal circumstances, this material would solidify into grains or crystals, but on HD 189733b, the heat is so intense that these silicates stay liquefied, suspended in clouds of vaporized rock. When powerful winds clocking in at a mine blowing 4,000 miles per hour sweep across the planet, they whip these molten droplets into a sideways deluge. Picture standing on the surface if you could survive a millisecond and seeing a horizon of blue fire, with razor-sharp glass shards slicing through the air at 7 times the speed of sound. What makes this planet even more nightmarish is its eerie stillness beneath the chaos. Unlike Earth, where weather systems churn and shift, HD 189733b is tidally locked, meaning one side perpetually faces its host star while the other drowns in eternal night. The temperature difference between these hemispheres creates supersonic jet streams that barrel around the planet, dragging the glass storms in their wake. And if the winds weren't deadly enough, the pressure here is crushing 20 times heavier than Earth's, turning any hypothetical visitor into a pancake before they even noticed the glass daggers in the air. Astronomers discovered this horror show by studying the light filtering through the planet's atmosphere during transits. The spectral signatures revealed not just silicate clouds, but traces of ionized hydrogen bleeding off into space, a sign the atmosphere is being slowly shredded by stellar radiation. It's a glimpse into the fate awaiting many hot Jupiters, gas giants orbiting too close to their stars, doomed to have their atmospheres boiled away over time. What's haunting is the contrast, a world that looks like a serene blue jewel from afar, but up close, it's a slaughterhouse of physics. HD 189733b is a reminder that the universe doesn't care about aesthetics. Beauty can hide the most violent secrets. So the next time you admire a sapphire sky on Earth, remember, somewhere out there, a planet wears the same color like a mask, concealing a storm that would flay a starship to its bones in seconds. Rising from the heart of our galaxy like twin gargantuan balloons, the Fermi bubbles stretch 50,000 light-years into space, one above the Milky Way's disk, one below. Discovered in 2010 by NASA, a Fermi gamma-ray telescope, these colossal structures glow with high-energy gamma rays, their edges sharply defined against the darkness as if someone had blow-torched a pair of perfect bubbles into the fabric of space. Each bubble contains enough energy to power 100,000 supernova, yet their origin remains one of the most heated debates in astrophysics, the leading theory. A cataclysmic tantrum from Sagittarius, a star, our galaxy's central black hole. Roughly 2 to 4 million years ago, this sleeping giant might have briefly awakened as a quasar, gorging on vast amounts of gas and spearing jets of high-energy particles straight up and down from the galactic plane. The resulting shockwaves would have inflated these bubbles like cosmic bellows, leaving behind a ghostly imprint visible only in gamma rays. Supporting this idea are the bubble's symmetrical structure, precisely aligned with the black hole's axis, and the presence of similar, smaller bubbles spotted around other galaxies. But not everyone's convinced. Some researchers argue the Fermi bubbles could be the cumulative aftermath of thousands of supernova erupting in the galaxy's crowded core. When massive stars die in rapid succession, their combined explosions can create galactic winds powerful enough to carve out such structures. There's even a third camp proposing these bubbles are relics of dark matter annihilations, with hypothetical particles colliding and releasing gamma rays as they perish. What makes this mystery so compelling is the time capsule it represents. The bubble's pristine edges suggest whatever created them happened quickly, a single violent outburst rather than a slow, ongoing process. Their gamma-ray glow also reveals a hidden highway of cosmic rays, particles accelerated to near light speed, possibly by the same event. And here's the kicker, we might have witnessed the aftermath. In the constellation Orion, there's a vast ionized gas cloud called the Smith Cloud that shows signs of being scorched by a massive energy wave around the same time the bubbles likely formed. Could this be shrapnel from Sagittarius, a star's ancient tantrum? The Fermi bubbles aren't just fossils, they're a reminder that even our seemingly quiet galaxy has a volatile past. Future telescopes could settle the debate by hunting for chemical traces in nearby stars or measuring the bubble's magnetic fields for clues about their birth. Until then, they loom silently over us, twin enigmas whispering of a time when the Milky Way's heart erupted in a firestorm we're only now learning to see. Amid the swirling chaos of the cosmos, where most nebulae twist into messy spirals or jagged shards, the red rectangle nebula stands out like a geometric masterpiece. Located about 2,300 light-years away in the constellation Monoceros, this cosmic anomaly looks less like a celestial cloud and more like a glowing, X-rayed honeycomb, its nested layers of gas forming near-perfect rectangles within rectangles. The precision is so uncanny, early astronomers actually debated if it was some kind of interstellar structure built by intelligence. But the truth is even wilder. This is the handiwork of two dying stars locked in a gravitational duet, painting the void with mathematically perfect brushstrokes. At the nebula's heart lies HD 44179, a binary system where one star has already shed its outer layers, while its companion whips those expelled gases into shape. As the duo orbits, their gravitational dance channels the outflowing material into two opposing cones, like twin fire hoses spraying into space at precise angles. The edges of these cones carve sharp lines into the surrounding gas, while dust particles scatter the star's light, giving the nebula its eerie red hue. But why rectangles instead of smooth curves? The secret lies in shock waves. When faster-moving material slams into slower streams, it creates standing waves. Think of how a speedboat's wake forms crisp angles on calm water. These shocks nudge atoms into alignment, reinforcing the geometric pattern with every stellar breath. What's truly baffling isn't just the symmetry, it's the durability. Most nebulae dissolve into randomness within millennia, battered by stellar winds or nearby supernova. Yet the red rectangle has maintained its structure for at least 14,000 years, a testament to the delicate balance between its star's outflow and the resisting interstellar medium. Even more bizarre, the nested rectangles aren't static. They're expanding at over 100,000 miles per hour, yet their proportions stay locked in perfect harmony, like a cosmic zoom lens preserving the shape as it grows. Theories abound about how such precision emerges from chaos. Some suggest magnetic fields act like invisible scaffolding, guiding the gas into orderly lanes. Others propose the binary star's orbit resonates with the outflow's natural frequency, amplifying the symmetry like a musical note vibrating a wine glass. But perhaps the most humbling idea is that we're witnessing a fleeting cosmic coincidence, a brief window where all the variables align before time erodes the perfection. For now, the red rectangle remains a laboratory for the impossible. It challenges our assumptions about how disorderly space can birth order, proving that even in the frenzy of stellar death, the universe has a hidden flair for geometry. And when it finally fades, its legacy will linger, a reminder that somewhere out there, against all odds, chaos can still create art. Astronomers have stumbled upon something that defies all expectations: enormous, ghostly rings glowing in radio waves, spanning entire galaxies yet invisible in any other light. They call them odd radio circles, or ORC, and these cosmic halos are so perplexing that even their discoverers initially assumed they must be glitches in the data. Imagine finding perfect smoke rings floating in space, each one big enough to swallow 1,000 Milky Ways with no clear source or explanation. That's the enigma of ORC's structures, so vast they rewrite the rules of what we thought possible. The first ORC was spotted in 2019, hiding in plain sight within decades-old radio telescope archives. At first glance, it looked like a faint, circular smudge, easy to dismiss as interference. But as researchers combed through more data, they found others, each one an almost perfect ring of radio emission with a galaxy near its center, stranger still. These rings don't appear in optical, X-ray, or infrared telescopes. They're radio phantoms detectable only in wavelengths our eyes can't see. So what could possibly carve such colossal rings into the fabric of space? One leading theory points to shockwaves from an ancient catastrophe, perhaps two supermassive black holes colliding at the heart of a galaxy, sending ripples through intergalactic gas like a stone dropped in a pond. The energy from such a merger could heat the surrounding material, creating expanding shells that glow in radio waves. Another idea suggests these are the aftermath of a starburst event, where a galaxy briefly births stars at a furious rate, then unleashes cosmic winds strong enough to blow bubbles in the surrounding gas. But there's a wilder possibility lurking in the margins. ORCs might be the fingerprints of something even more exotic, like a wormhole's throat, a tunnel through space-time predicted by Einstein's equations but never observed. If a wormhole's intense magnetic fields interacted with surrounding plasma, it could theoretically sculpt these perfect rings, or they could be the remnants of a quasar's death cry, a final burst of energy from a dying supermassive black hole. What makes ORCs so tantalizing isn't just their mystery, it's their scale. These rings stretch up to 2 million light-years across, dwarfing the galaxies they encircle. Their symmetry hints at forces far more precise than the chaotic collisions we usually see in space. And because they're invisible except in radio waves, they force us to question what else might be hiding in plain sight, just beyond the limits of our perception. For now, ORCs remain cosmic riddles, challenging us to rethink everything from galactic evolution to the nature of spacetime itself. Every new discovery peels back another layer, proving the universe still has cards it hasn't shown us. And somewhere out there, these silent rings keep expanding, carrying secrets we've only begun to unravel. When astronomers first spotted KIC 8462852, better known as Tabby's star, they thought their instruments were broken. Nestled in the constellation Cygnus, this seemingly ordinary star did something no other had ever done. Its light flickered unpredictably, plunging by up to 22% for days at a time before rebounding just as mysteriously. The dips weren't periodic like a planet's transit. They were chaotic, jagged, as if something massive and irregular were passing in front of the star, blocking its light in cryptic patterns. And that's when the wildest theory took hold. What if this wasn't natural at all? What if we were seeing the shadows of an alien megastructure, a Dyson swarm under construction? The idea wasn't entirely far-fetched. In the 1960s, physicist Freeman Dyson theorized that advanced civilizations might harness their star's energy by building vast arrays of solar collectors, a concept now called Dyson spheres. Tabby's star's bizarre light curves seemed to fit. Maybe we were catching glimpses of colossal panels orbiting their sun, occasionally blotting out its glow. For a while, even seasoned scientists entertained the possibility, but the universe, as usual, had a stranger explanation up its sleeve. Years of painstaking observation revealed the true culprit, or at least part of it. The star's dimming wasn't caused by sleek alien tech, but by colossal clouds of dust. Not the uniform dust we see in young planetary systems, though. This dust was uneven, clumpy, and oddly asymmetric, swirling around Tabby's star in a way that defied easy explanation. Some dips lasted days, others stretched for weeks, suggesting particles of varying sizes from fine grains to pebbles, all orbiting in a chaotic dance. Spectroscopy confirmed it. The star's light reddened as it dimmed, a telltale sign of scattering by dust particles. Yet the mystery only deepened. Where did this dust come place? Normal stellar aging couldn't account for it. Tabby's star isn't old enough to be shedding material so violently, and it shows no signs of the gas that usually accompanies such outbursts. One theory suggests a cataclysmic collision, perhaps a moon-sized object shattered in the star's gravity, scattering debris across its orbit. Another proposes a family of evaporating comets, though the scale required would dwarf anything in our solar system. The most tantalizing idea: the dust might be trapped in resonant orbits, shepherded by an unseen planet's gravity, creating a feedback loop of fragmentation and redistribution. But here's the kicker: even dust doesn't explain everything. Some of the star's long-term dimming, a gradual fade of nearly 3% over a century, hints at something larger at play. Could the dust clouds be seasonal, waxing and waning as they spiral inward? Or is there another, darker structure lurking farther out, something we've yet to detect? The truth is, Tabby's star remains one of astronomy's most stubborn puzzles, a reminder that the cosmos thrives on ambiguity. What makes this star so captivating isn't just the failed alien hypothesis, it's the way it keeps surprising us. Every answer spawns new questions, every theory meets an exception. Future telescopes might unravel its secrets, or it might cling to its mysteries for decades. Either way, Tabby's star stands as a beacon of cosmic humility, proving that sometimes the universe's most ordinary-looking objects hide the most extraordinary stories. And somewhere in its flickering light, there's a lesson. The line between science and speculation is thinner than we think, and the truth is often stranger than even our wildest dreams. Dead stars don't just fade quietly into the cosmic background. Some become ruthless survivors, dragging entire worlds through the apocalypse and remaking them in their own image. Meet the pulsar planets, a handful of nightmarish worlds orbiting the fastest spinning corpses in the universe. These aren't just any dead stars, they're pulsars, the lighthouses of the cosmos, blasting out beams of radiation so intense they could strip a planet bare in seconds. Yet against all odds, planets have been found circling these radioactive tombs, proof that even the universe's most violent explosions can't always erase every trace of what came before. The first pulsar planet discovery in 1992 shattered every assumption about where life could exist. Astronomers studying a pulsar called PSRB 1257+12 noticed tiny anomalies in its timing, millisecond variations caused by the gravitational tug of not one, but three orbiting worlds. The implications were staggering. Pulsars are born from supernovas so powerful they can outshine entire galaxies for weeks. For planets to survive such an explosion, they'd need to be either incredibly lucky or impossibly tough. Most likely, these worlds weren't the original planets of the star system at all, but second-generation orphans forming from the debris left behind after the supernova's fury subsided. Picture a star exploding with enough force to vaporize Mercury, Venus, and Earth, only for new planets to emerge from the ashes like phoenixes made of neutron-rich rubble. But the real shocker, life might still find a way here. Pulsar planets exist in a perpetual hellscape, bathed in X-rays and gamma rays that would sterilize Earth in moments. Yet extremophiles in our own planet's most hostile environments, bacteria thriving in nuclear reactor coolant, fungi growing inside Chernobyl's ruins, hint at life's absurd adaptability. On a pulsar planet, life wouldn't rely on sunlight, but on the pulsar's own radiation, converting deadly energy into biological fuel. The night sky would be a relentless strobe light, flashing hundreds of times per second as the pulsar spins, casting shadows in eerie, rapid-fire flickers. The ultimate irony, these might be some of the most precisely timed worlds in the galaxy. Pulsars are nature's atomic clocks, their rotations so regular they rival human-made timekeepers. Any civilization evolving here could chart cosmic events with millisecond precision. Their calendars sync to the dead star's heartbeat. That is, if they could survive the radiation storms, the gravitational chaos, and the constant bombardment of high-energy particles screaming through their atmosphere. What makes pulsar planets so haunting isn't just their existence, it's what they represent. They're monuments to cosmic resilience, proof that planets can outlast their stars' deaths and cling to existence in the most hostile corners of space. And if life can emerge here, in the wreckage of a supernova's aftermath, then maybe nowhere in the universe is truly barren. So the next time you hear the steady click, click, click of a pulsar's radio signal, remember, somewhere in that lethal glow, a world might be holding on, spinning in time with the corpse of its creator. Deep in the Milky Way's heart, something stirs, a force so immense it could send tidal waves of radiation surging across the galaxy, reaching all the way to our tiny blue planet. These are galactic superwaves, hypothetical cosmic tsunamis of high-energy particles erupting from the core, theorized to sweep through space every few thousand or million years. Imagine a shockwave of gamma rays and cosmic radiation so powerful it could scorch atmospheres, mutate DNA, and rewrite the history of life on Earth. This isn't science fiction, it's a fringe but chilling theory that our own galactic center might be the silent architect of mass extinctions. The idea hinges on Sagittarius, a star, our galaxy's supermassive black hole. Normally quiet, it occasionally feeds on dense clouds of gas, triggering violent outbursts of energy. Some researchers suggest these eruptions could accelerate particles to near light speeds, creating an expanding bubble of lethal radiation. Unlike a supernova's one-time blast, a superwave would be a sustained onslaught, lasting centuries, enough time to bathe every star system in its path in a shower of ionizing radiation. The evidence, layers of radioactive isotopes like iron-60 buried in Earth's ocean floors and lunar soil, dating back to periods oddly coinciding with past extinction events. But here's where the controversy ignites. Mainstream astronomy remains skeptical. No superwave has ever been observed directly, and the isotopic spikes could stem from more local supernova. Critics argue the galaxy's magnetic fields would scatter such particles long before they reached us. Yet proponents counter with eerie patterns. The Permian-Triassic extinction, Earth's deadliest die-off, coincided with a dramatic drop in ozone levels, as if something had shredded our protective atmospheric layer from space. Even more provocative are studies linking superwave cycles to climatic shifts like ice ages, suggesting these cosmic barrages might not just kill life, they could nudge evolution itself. The wildest twist, we might be overdue. If superwaves follow even a loose rhythm, the next one could already be brewing in the galactic core, invisible to us until its leading edge arrives. Future telescopes monitoring Sagittarius, a star's activity, could provide early warnings, but for now, the theory remains a ghost in the data, a haunting reminder that Earth isn't just shaped by its own geology, but by the invisible hand of our galaxy's restless heart. Whether myth or reality, galactic superwaves force us to confront a humbling truth. The universe doesn't just watch life unfold, it sometimes reaches out and stirs the pot. Most galaxies evolve like living organisms, growing, merging, and transforming over billions of years. But NGC 1277 didn't get the memo. This cosmic relic, lurking 240 million light-years away in the constellation Perseus, is the astronomical equivalent of a prehistoric insect trapped in amber, a pristine snapshot of the universe's fiery youth frozen in time. Unlike modern galaxies brimming with young, blue stars and swirling arms, NGC 1277 is a vault of ancient red stars, virtually unchanged since the universe was just a few billion years old. It's as if someone pressed pause on galactic evolution and forgot to hit play again. What makes this galaxy so bizarre isn't just its age, it's how it dodged the forces that reshape everything else. Most galaxies grow by cannibalizing neighbors or accreting fresh gas to birth new stars, but NGC 1277 somehow starved itself out of the cosmic food chain. It's packed with twice as many stars as the Milky Way, crammed into a space just a quarter the size, yet it's devoid of the star-forming gas that fuels galactic renewal. Theories suggest it might have been born in an unusually dense region of the early universe, where it gobbled up all nearby material in a frenzy, then got stranded in a void cut off from further growth. Alternatively, its monstrous central black hole, one of the largest ever found relative to its host galaxy, could have sterilized it early on, blasting away potential star fuel with violent outbursts. But the real puzzle is how this fossil survived the cosmic demolition derby around it. The Perseus cluster, where NGC 1277 resides, is a gravitational war zone where galaxies routinely collide and merge. Yet this relic somehow emerged unscathed, like a medieval castle standing untouched amid a modern metropolis. Its stars orbit in bizarre, tightly wound patterns, suggesting it's avoided major disruptions for nearly the entire age of the universe. Even more baffling, it's not alone. A handful of other relic galaxies have been spotted, hinting at a lost population of cosmic time capsules hiding in plain sight. The implications are profound. If NGC 1277 truly represents the universe's toddler phase, studying it could reveal secrets about how galaxies formed before the chaos of collisions and star births scrambled their original blueprints. Its ancient stars act like celestial archaeologists, preserving the chemical fingerprints of the early cosmos, and its existence forces us to ask what other relics are lurking in the shadows, untouched by time. For now, this galactic dinosaur remains a tantalizing exception, a rule breaker that challenges our understanding of how the universe grows up, and in its stubborn refusal to change, it offers us something rare, a direct line to the distant past written in starlight. Earth doesn't just have one moon, it occasionally picks up hitchhikers. These cosmic transients, dubbed mini-moons, are asteroids briefly captured by our planet's gravity, swirling around us in chaotic, looping orbits before vanishing back into space. Take 2020 CD3, a car-sized visitor that circled Earth for nearly 3 years before slipping away in 2020. At the time, it became only the second confirmed temporary moon ever discovered. A celestial passer-by so faint it evaded detection until it was already leaving. What makes these fleeting companions so fascinating isn't just their rarity, it's the way they dance on the edge of gravitational possibility. Unlike our steady, predictable moon, mini-moons follow bizarre, unstable paths dictated by a cosmic tug-of-war. Earth's gravity snags them as they drift by, but the sun's far stronger pull constantly disrupts their orbits, turning their trajectories into spiraling messes. Some loop around us for months, others linger for decades before getting flung back into interplanetary space. Their orbits resemble tangled spaghetti rather than clean ellipses, twisting into figure eights or corkscrews as they navigate the competing pulls of Earth, the Sun, and even the Moon itself. That chaos makes them nearly impossible to track. Most are spotted purely by accident when telescopes catch a streak of movement against stationary stars. The challenge in studying these ghostly guests lies in their speed and stealth. Mini-moons tend to be tiny, often just a few meters across, and their erratic paths mean they rarely stay in one place long enough for follow-up observations. By the time astronomers confirm their existence, they're already vanishing into the void. 2020 CD3, for instance, was found just 2 months before its escape. And because their surfaces are often dark as coal, reflecting little sunlight, they're invisible to most surveys until they're practically on top of us. Yet these cosmic mayflies could hold keys to planetary secrets. Many mini-moons are thought to originate from the asteroid belt, offering pristine samples of material unchanged since the solar system's birth. Some might even be artificial space junk from old missions, mistaken for natural objects until their orbits betray their human origins. Future missions could target these temporary moons, using them as low-energy pit stops for asteroid mining or deep space exploration. Imagine a future where astronauts hitch rides on passing rocks, leveraging their brief captivity to hopscotch across the solar system, the most tantalizing possibility. Mini-moons might not be so rare after all. Current estimates suggest at least one is orbiting Earth undetected at any given time, some no bigger than a washing machine, others as large as a house. New telescopes like the Vera C. Rubin Observatory, set to scan the entire southern sky every few nights, could finally reveal this hidden population, turning what was once theoretical into a routine discovery. Until then, these phantom moons remain celestial riddles, here one moment and gone the next, reminding us that even Earth's gravitational embrace is just a temporary stopover in the grand orbital highway of space. Venus doesn't just have a storm, it has a nightmare. At the planet's south pole, a colossal double-eyed vortex spins endlessly, a tempest so alien it makes Earth's hurricanes look like gentle breezes. This isn't just a swirling mass of clouds, it's a towering funnel of sulfuric acid and superheated gas, stretching over 1,200 miles wide and rotating every 2.6 Earth days. The storm's most bizarre feature, its twin eyes, two distinct centers of rotation nested within each other like a cosmic infinity symbol, defying everything we know about atmospheric physics. What makes this vortex so unlike anything on Earth is Venus's brutal atmosphere. While our hurricanes draw energy from warm ocean water, Venus has no oceans, just a scorching, toxic blanket of carbon dioxide with surface pressures 92 times heavier than Earth. Its hurricane-force winds aren't confined to the surface. They rage from the ground up to 60 miles high, propelled by a phenomenon called superrotation. The entire atmosphere whips around the planet 60 times faster than Venus itself rotates, creating a planet-wide maelstrom where storms don't just form, they become permanent fixtures. Scientists first spotted the vortex in 2006 using the European Space Agency's Venus Express orbiter. Infrared images revealed the storm's shape-shifting nature, sometimes appearing as a tight double spiral, other times stretching into a wobbly dumbbell. Unlike Earth's hurricanes, which weaken over land, this vortex has persisted for decades, possibly centuries, fed by the planet's relentless atmospheric churn. The leading theory suggests polar vortices form as hot gas from Venus's equator rushes toward the poles, only to collide and plunge downward, creating a whirlpool effect. But why two eyes instead of one? Turbulence and the planet's rapid atmospheric circulation likely split the vortex into dual cores, a behavior so rare that lab simulations struggle to replicate it. The deeper mystery lies in what the vortex reveals about Venus's climate. Earth's poles are relatively calm, but Venus's are cauldrons of chaos with temperatures and pressures that fluctuate wildly. Some researchers think the vortex acts like a pressure valve, regulating the planet's hellish weather system. Others suspect it's a side effect of solar heating, with sunlight baking the atmosphere into a turbulent mess. Either way, this storm is a window into why Venus, Earth's twin in size, become a furnace while our planet thrived. Here's the kicker: the vortex might not be alone. Recent observations hint at a similar structure at Venus's North Pole, though it's harder to study due to limited probe coverage. If true, it means the planet's poles are locked in a mirrored dance of perpetual storms, a symmetry as beautiful as it is terrifying. Future missions like NASA Veritas aim to map these vortices in detail, peeling back the layers of their chaos. Until then, the Venus vortex remains a mesmerizing enigma, a reminder that even in our own solar system, nature's imagination knows no limits. So the next time you see footage of Earth's hurricanes, remember, somewhere nearby, a far stranger storm has been spinning for centuries, and we're only beginning to understand its secrets. Black holes don't just devour matter, they spit it back out with cosmic force, belching out jets of plasma and radiation long after their meals are supposedly over. These delayed eruptions, nicknamed black hole burps, reveal a startling truth: even the universe's most voracious eaters have indigestion. Take the supermassive black hole at the center of galaxy SJ 1354+1327. In 2017, astronomers watched as it ejected a colossal bubble of gas, not during its feeding frenzy, but a staggering 100,000 years after swallowing a star. The blast traveled at nearly light speed, stretching over 30,000 light-years, and carried enough energy to power star formation across an entire galaxy. This isn't just a rare cosmic hiccup. Black holes across the universe follow the same bizarre pattern, slurping down gas and stars only to regurgitate chunks of them eons later. The delay happens because black holes don't digest cleanly. Swallowed material doesn't vanish instantly. It spirals inward through an accretion disk, a swirling maelstrom of superheated plasma. Friction and magnetic fields within this disk can trap some matter for millennia, like food stuck in a cosmic esophagus, before violent instabilities finally eject it. These outbursts aren't gentle, they're shockwaves of energy so powerful they can carve cavities in intergalactic gas, halting star formation across vast regions of space. The implications rewrite how galaxies evolve. For decades, scientists assumed black holes were simple destroyers. Now we know they're paradoxically creative. Their belchers inject heavy elements forged in their disks back into space, seeding future generations of stars and planets. The energy from these outbursts also acts like a galactic thermostat, heating surrounding gas so it can't cool and collapse into new stars. Without these belches, galaxies might exhaust their star-forming fuel too quickly, burning out in a blaze of unsustainable birth, the most jaw-dropping example. The Phoenix Cluster's central black hole, which erupts in rhythmic burps every few million years. Each explosion creates sound waves in the surrounding gas, actual notes in the cosmic symphony that astronomers can map like sonar. These pulses regulate star formation with clockwork precision, proving black holes don't just shape their galaxies, they conduct them. What's truly humbling is the timescale. A black hole's meal might last months, but its aftermath unfolds over epochs. These delayed outbursts mean a black hole's influence isn't confined to its active phase, it's a celestial time bomb, with effects that ripple across cosmic history. So the next time you picture a black hole as a silent vacuum, think again. It's more like a slumbering dragon, capable of exhaling fire long after its feast, and in doing so, sculpting the universe itself. At the very edge of observable reality, where the afterglow of the Big Bang whispers its secrets, scientists stumbled upon something so unsettling they nicknamed it the axis of evil. This isn't some cosmic supervillain, it's a bizarre pattern etched into the cosmic microwave background, the CMB, the oldest light in the universe, and what makes it so controversial. This primordial radiation isn't randomly speckled like static on a TV screen. It's aligned almost as if the universe has a preferred direction, one that suspiciously mirrors our solar system's plane. To physicists, this isn't just odd. It's like finding a compass that always points toward your backyard, no matter where you stand in the cosmos. The CMB should be the ultimate cosmic democracy, a uniform snapshot of the infant universe, its temperature variations distributed evenly like breadcrumbs from creation. But when satellites like WMAP and Planck mapped its subtle fluctuations, they revealed a spine-chilling quirk. Certain large-scale patterns align eerily with the ecliptic, the flat disk where Earth and the planets orbit the Sun. The odds of this happening by chance, less than 1 in 10,000. Some researchers argue it's a statistical fluke, a cosmic coincidence in a dataset brimming with anomalies. But others whisper a far more radical idea. What if this alignment is a fossil, a scar from something before the Big Bang? Imagine the implications. If the CMB's axis isn't random, it could mean our universe inherited structure from a predecessor, a collapsed universe that rebounded into ours, imprinting its geometry like a phantom fingerprint. Alternatively, it might hint at undiscovered physics warping spacetime on scales we've yet to comprehend. Skeptics counter that the alignment could be an artifact of measurement errors or foreground interference from our own galaxy. Yet, even after accounting for these, the signal persists, gnawing at the foundations of cosmology's gold standard, the cosmological principle which insists the universe has no special direction or center. The debate gets fiercer when you consider how this axis manifests. The CMB's quadrupole and octupole moments fancy terms for its large-scale hot and cold spots aren't just aligned with the solar system. They also correlate with the universe's overall motion through space. It's as if the cosmos is subtly acknowledging our tiny corner of existence, a notion so egocentric it makes Ptolemy's Earth-centered model look humble. Mainstream cosmology recoils at such heresy, preferring to attribute the anomaly to systematic errors or the statistical noise of a single observable universe. But with each new study, the axis of evil refuses to vanish into obscurity. Here's where it gets existential. If the axis isn't a fluke, it could rewrite our origin story. Some theorists propose a pre-Big Bang eon where a prior universe's collapse birthed ours, leaving behind gravitational echoes. Others suggest our universe is one bubble in a vast multiverse, with neighboring realms tugging at the fabric of space-time like invisible puppeteers. The most unsettling possibility, that we're seeing evidence of a cosmic boundary, a place where the universe stops with our solar system somehow privileged to sit near its center. For now, the axis of evil remains a ghost in the data, too persistent to ignore but too controversial to embrace. Future telescopes might settle the debate by mapping the CMB with even finer precision, hunting for secondary patterns or polarization signals that could confirm or dismantle the anomaly. Until then, it stands as a cosmic riddle, a reminder that the universe, for all its grandeur, might still be keeping its deepest cards close to its chest. And whether it's a flaw in our models or a crack in reality itself, one thing's certain: the cosmos never stops challenging what we think we know. At the brink of collapse, where gravity and quantum forces wage an endless tug of war, spins a cosmic oddity so dense it defies comprehension. MSP J0740 plus 6620, the heaviest neutron star ever discovered. This celestial heavyweight packs more than twice the Sun's mass into a sphere no wider than Manhattan, teetering so close to the black hole threshold that it's rewriting the rules of physics. One wrong move, one extra grain of cosmic sand, and it would vanish forever, crushed into oblivion by its own weight. Yet here it remains, pulsing with eerie precision, a lighthouse at the edge of annihilation. What makes this neutron star so extraordinary isn't just its record-breaking mass, it's the impossible physics keeping it intact. Neutron stars are born from supernova, their cores squeezed so tightly that protons and electrons fuse into a sea of neutrons. Under normal circumstances, there's a limit to how much pressure this neutron soup can withstand before it caves into a black hole. But MSBJ0740 plus 6,620 laughs in the face of that limit. Its existence suggests something bizarre is happening at the quantum level. Perhaps an unknown force, some exotic particle interaction, or a property of matter we've yet to name is propping it up against gravity's relentless pull. Scientists discovered this cosmic tightrope walker using a trick of relativity. Orbited by a white dwarf companion, the star's gravity bends space-time so severely that light from its partner arrives delayed, an effect called the Shapiro delay. By measuring precisely how long those photons take to reach us, astronomers calculated the star's mass, a staggering 14 solar masses, right on the edge of theoretical predictions. But here's the catch: no equation can fully explain how matter behaves under such extreme conditions. If neutron stars get any denser, the rules we know break down entirely, leaving us staring into the abyss of quantum uncertainty. The implications ripple far beyond this one star. MSBJ0740 plus 6,620 is a natural laboratory for states of matter that can't exist on Earth. Its core might harbor quark-gluon plasma, a primordial soup last seen microseconds after the Big Bang, or strange matter, a theoretical substance where neutrons dissolve into free-floating quarks. Some theories even suggest its crushing gravity could warp particles into hyperons, exotic hybrids that blur the line between matter and energy. Every pulse from this star carries encrypted clues about physics at energies no collider could ever replicate. Yet the greatest mystery isn't what's inside, it's why we can see it at all. Neutron stars this massive should collapse instantly, yet this one spins steadily, beaming radio waves like a metronome. Is there an unseen quantum barrier halting its demise? Or are we witnessing the slow-motion death of a star, its final moments stretched across millennia? Every second it persists, it taunts us with questions about the universe's most fundamental laws. And somewhere out there, other impossibly dense stars might lurk, each one a ticking time bomb, each one daring us to rethink what matter and reality itself can endure. Most cosmic clouds drift lazily through space, but not HVC 040 plus 01-282. This rogue gas cluster barrels through the Milky Way at 700,000 miles per hour, fast enough to cross the distance from Earth to the Moon in under 24 minutes. Astronomers call it a high-velocity cloud, but galactic bullet might be more fitting. Unlike typical interstellar gas that moves in sync with the galaxy's rotation, this cosmic projectile cuts perpendicularly across the Milky Way's disk, dragging a shockwave of superheated plasma in its wake. The mystery begins with its origins. Most high-velocity clouds are thought to be galactic hitchhikers, condensed gas from the Milky Way's outer halo falling inward. But HVC 040's trajectory and composition scream outsider. Its path suggests it didn't originate here. It might be debris from a long-ago collision with a dwarf galaxy, or even intergalactic gas snagged during the Milky Way's journey through the local group. The cloud's metallicity, the abundance of elements heavier than hydrogen and helium, hints at a violent past. These heavier atoms, forged in stellar explosions, suggest this gas once cycled through stars before being ejected into the void. What happens when a gas cloud slams into a galaxy at cosmic speeds? Chaos, but also creation. As HVC 040 plows through the Milky Way's diffuse hydrogen, the collision unleashes enough energy to light up newborn stars. The shockwaves compress surrounding gas, triggering pockets of star formation like sparks from a hammer strike. Ironically, this destructive force might be seeding the next generation of stellar nurseries. But there's a darker side. The cloud is also stripping away the galaxy's existing gas reserves. Every atom torn loose by this high-speed encounter is matter that won't fuel future stars, slowly starving the Milky Way of its raw materials. The real enigma is its durability. Ordinary gas clouds would disintegrate under such extreme forces, yet HVC 040 holds together with eerie cohesion. Some researchers speculate it's wrapped in a cocoon of dark matter, an invisible gravitational scaffold that keeps it intact despite the tidal forces trying to shred it. Others propose magnetic fields threading through the cloud act like cosmic stitching, reinforcing its structure. If true, it means this bullet isn't just passing through, it's armored against the galaxy's attempts to dissolve it. Here's the kicker: we might be witnessing a fleeting moment in a much larger cycle. Galactic collisions, even minor ones, are thought to be key players in how galaxies grow and evolve. The Milky Way has likely absorbed thousands of such clouds over its lifetime, each one contributing or stealing a fraction of its star-forming fuel. Future observations could reveal whether HVC 040 is a lone wolf or part of a hidden population of intergalactic interlopers, silently shaping galaxies from the shadows. So the next time you gaze at the Milky Way's serene band of light, remember, it's a battlefield where invisible bullets fly, where destruction and creation collide, and where the fate of stars hinges on the chaos of clouds we're only beginning to understand. Astronomers once celebrated Fomalhaut b as one of the first exoplanets ever directly photographed, a gleaming dot orbiting the bright star Fomalhaut 25 light-years away. But when they looked again, it was gone, not hiding, not dimmed, vanished without a trace. The object that had been hailed as a groundbreaking discovery turned out to be something far stranger. A ghostly cloud of dust, the aftermath of a cataclysmic collision between two planet-sized bodies. What we thought was a world was actually a funeral shroud, the remains of a cosmic wreck so violent it briefly outshone its own star. The mystery began in 2008, when Hubble's images revealed a tiny speck moving predictably around Fomalhaut, nestled within a vast debris ring that resembled our solar system's Kuiper belt. For years, scientists treated it as a textbook example of a gas giant, but something was off. Unlike normal planets, Fomalhaut b didn't emit infrared heat, it just reflected light erratically, flickering like a candle in the wind. Then, by 2014, it began to expand, its edges blurring until it dissolved into the void. The verdict: we'd witnessed the aftermath of a disaster. Two icy worlds, each possibly hundreds of miles wide, smashing together at cosmic speeds. The impact would have unleashed enough energy to vaporize both bodies instantly, leaving behind a glowing debris field that slowly dispersed over a decade. What makes this phantom planet so haunting isn't just its disappearance, it's the scale of destruction it represents. The collision was recent, astronomically speaking. Based on the dust cloud's expansion rate, the crash likely occurred just a few years before Hubble first spotted it. For a brief moment, humanity's telescopes became time machines, capturing the aftermath of an event that would have lit up Fomalhaut's sky like a second sun. And if such chaos can happen there, it's probably happening everywhere. Young star systems might be war zones where protoplanets jostle for space and annihilate each other in spectacular crashes. The real lesson of Fomalhaut b is humility. Even with our most advanced tools, the universe loves to mislead us. A dot of light can be a planet, a dust cloud, or the echo of a catastrophe we'll never fully reconstruct. Other phantom planets might lurk in our data, waiting to reveal their true nature, or vanish before we understand them. It's a reminder that discovery isn't a straight line. Sometimes what we find isn't what we thought, and what we lose teaches us more than what we keep. So the next time you hear about a distant world, remember, in the cosmic dance of creation and destruction, even the most solid-seeming truths can evaporate like stardust. Deep in the heart of modern cosmology, a crack is forming, one that threatens to split our understanding of the universe along its seams. Scientists call it the Hubble tension, and it's not just some academic debate. This is a full-blown crisis where the cosmos itself seems to be giving us contradictory blueprints for its own expansion. On one side, we have meticulous measurements from the early universe, the cosmic microwave background painting a picture of how fast space should be stretching. On the other, observations of nearby stars and supernova show galaxies racing away from us significantly faster than those ancient clues predict. The discrepancy isn't a minor rounding error. It's a glaring 9% gap, like two clocks that should be perfectly synchronized but stubbornly tick at different speeds despite being built from the same rules. So what's really going on? The most unsettling possibility is that we're staring at the limits of our current physics. The standard model of cosmology, which has guided us for decades, might be missing a crucial ingredient, something invisible yet influential enough to warp the fabric of reality on universal scales. Some theorists suggest an unseen form of dark energy, more exotic than anything we've imagined, could be ramping up the universe's expansion like an accelerator pedal stuck in overdrive. Others propose that dark matter, the universe's hidden scaffolding, behaves differently than we thought, clustering in ways that subtly alter how galaxies move. Then there's the radical fringe, ideas that gravity itself might change strength over cosmic time, or that parallel universes could be leaking gravitational influence into ours. But before we rewrite the textbooks, there's a humbler explanation: human error. Measuring the universe's expansion relies on cosmic ladders, chains of observations where each step builds on the last. A tiny miscalibration in any rung, like the brightness of certain supernova or the distance to pulsating stars called Cepheid variables, could cascade into the tension we see today. The stakes couldn't be higher. If it's new physics, we're on the brink of a revolution akin to Einstein overturning Newton. If it's measurement bias, it's a sobering reminder of how hard it is to take the universe's pulse across billions of light years. The most tantalizing clues might come from blending both approaches. Recent data from the James Webb Space Telescope initially seemed to side with the early universe measurements, deepening the mystery. But then, like a cosmic plot twist, revised analyses suggested local observations might have been slightly off all along. The truth could lie somewhere in between, a mix of overlooked systematic errors and subtle, undiscovered forces nudging the cosmos off script. What makes the Hubble tension so electrifying isn't just the science, it's the drama. This is how breakthroughs happen. When nature refuses to fit our models, that's when we're forced to think bigger, dig deeper, and question assumptions we didn't even realize we'd made. Whether the solution hides in a telescope's calibration files or in the equations of a yet unwritten theory, one thing's certain: the universe is still full of surprises, and the Hubble tension is its latest and greatest riddle for our generation to solve. So the next time you look up at the night sky, remember, out there the stars aren't just moving, they're running from a mystery we've only just begun to chase. From diamond planets to zombified stars that refuse to die, we've traveled through a universe far stranger than fiction, where black holes spit up their meals after millennia, rogue planets wander the void alone, and entire galaxies devour each other in slow motion. These aren't just cosmic curiosities, they're radical rewrites of what we thought possible. Every bizarre fact shatters another assumption: that planets need stars, that death is final, that space is silent. The cosmos thrives on chaos, turning our tidy rules into cosmic comedy. What's truly humbling isn't the scale of these wonders, it's how ordinary they might be. The Diamond World 55 Cancri E, just one of thousands of exoplanets we've spotted. The Great Attractor's gravitational pull, a single thread in the invisible web that binds the universe. Even the axis-defying red rectangle nebula is a reminder: the universe doesn't do mundane. Its creativity outstrips our imagination at every turn, and here's the kicker: we've barely scratched the surface. The James Webb Space Telescope is already revealing galaxies older than they should be, while upcoming missions like the Vera C. Rubin Observatory will hunt for ghostly dark matter halos and interstellar nomads we can't yet conceive. Every answer breeds new questions. Are we missing entire dimensions hidden in plain sight? Could quantum echoes from before the Big Bang flicker in the void? The more we learn, the clearer it becomes reality's strangest chapters are still unwritten. So stay curious. The next time you look up at the night sky, remember, you're not just staring at dots of light. You're peering into a cosmic funhouse where stars scream, diamonds rain, and time itself bends to unseen rules. The universe has spent 13.8 billion years perfecting its surprises, and the best ones are still hurtling toward us, waiting for the right telescope, the right moment to flip everything we know on its head again. The only limit to what's out there, our willingness to keep looking.